Now we'll be looking at tangents to circles. And once again, just to remind you on how to do mathematics. So number and copy the examples, ask your tutor or teacher if there are any steps that you do not understand. Number your questions, and unless you have the ability to get fit while watching someone else run, you must do the questions on your own before watching the answers. Then mark your answers. If it is incorrect, write down the corrections and make sure you understand where you went wrong. This will enable you to do better the next time you attempt a similar sum. Now in this video, we are going to start by finding the equation of a tangent. And then we're going to look at lengths of a tangent from an external point. So the first example where we find the equation of a tangent says, find the equation of the tangent to the circle, x squared plus y squared minus 2x plus 2y minus 11 equals 0 at the point minus 2 and 1. Right, now what we need to do is we have the equation of the circle. And using this equation, we need to find the tangent. So if we have our circle, we need to find the tangent at the point. So that one goes through. The tangent touches the circle at one point exactly. And at the point minus 2 and 1. So how are we going to do this? Now, remember, a tangent is simply a straight line in the form y equals to mx plus c. So that is what we are looking for, that equation of that straight line. And that means we need to find the gradient. And then after we found the gradient, we can substitute in this point and then also find the c value. All right, and now when we look at this equation of this circle, it's not in standard form. So whenever you're given equation of a circle and it's not in standard form, 99% of the time you're going to have to first put it in its standard form, because the standard form tells you where is the center of the circle, and it also tells you what the radius of the circle is. So that's the first thing we're going to do. I'm just going to rearrange this. X squared minus 2x plus y squared minus plus 2y equals to 11. Then we're going to complete the square on that, and by this time you should be comfortable with completing the square. If you're not, definitely go and revise that. So we add the coefficient of x over 2 squared plus y squared plus 2y, add the coefficient of y, that's 2 over 2 squared, equals to, so on this side we added 1, and that side, and here we also added 1, because 2 over 2 is 1, 1 squared is just 1. So here we have, this one was taken over and became 11. So we have 11 plus 1 plus 1. Okay, now to put it in its square brackets, we have x, then we have minus and 1. So that's squared, and then plus the y plus 1, and that's squared. And on this side we have 12, 13. Okay, so there we have it in standard form. Now how is that going to help us to get the equation of this tangent? Now we know something about when a tangent touches the circle, this radius here, the line that comes from the center of the circle and to the point where the tangent touched, these two lines, the tangent and that line, is perpendicular to each other. And what do we know about perpendicular lines? We know that their gradients, if I find the product of the gradients, that's equal to minus 1. Now we can also, the other thing we know about finding this equation, we know now where what this point is, this center point. That's going to be 1 and minus 1. All right, and now we have something to find the gradient of this line with. And then after we found that gradient, we can then find the gradient of the tangent using the gradient of a perpendicular line. So to find that gradient, we have gradient is y2 minus y1 over x2 minus x1, and if we substitute that in, we've got 1 minus negative 1 over 2, or minus 2 minus 1. So this gives me 2 over negative 3. So this is minus 2 over 3. And now, how do I find the perpendicular gradient? Remember, the shortcut was just to say I take my gradient, and to find the perpendicular gradient, I swap the numerator and denominator around and I change the sign. So this then just becomes 3 over 2, or positive 3 over 2, since this was negative 2 over 3. Okay, now we have the gradient of a straight line, and we have the point that we can substitute into, because that straight line goes through the point minus 2 and 1. And then we substitute in these values in this equation, y minus y1 equals to gradient times x minus x1. And this is y minus negative, or minus 1 equals to, the gradient is 3 over 2, then x minus negative 2. Okay, and let's simplify. So y minus 1 equals to, so this 3 over 2 goes inside, 3 over 2x. This becomes plus 2. And if I multiply the 3 over 2 with the 2, the 2's will cancel. So I'm left with plus 3. And then finally, we can just take the 1 over, and then we'll be ending up with y equals to 3 over 2x plus 4. Because if I add 1 on this side, I get plus 4. And there we have it. This is then the tangent to the circle, to this circle at that point. Now for question 31.1, so we want to find the equation of the circle. And this one is quite easy. We already have our circle in its standard form. So if I draw my circle, I already know that the point, the center point, or point at the center of the circle, is going to be 3 and minus 1. And then my tangent, not that it really is exactly over there, but just to get an idea, is there at this point 5 and 3. Okay, so basically we can first start off by getting the gradient of this line from the center of the circle to the circle itself, and that line is perpendicular to the tangent that touches the circle at that point. Alright, so we're going to start off by saying the gradient is equal to y2 minus y1 over x2 minus x1, and we substitute in our value, so we have 3 minus negative 1 over 5 minus 3, and this gives me 4 over 2, and that's equal to 2. Okay, now if my gradient of this line over here is equal to 2, what is the perpendicular gradient, the line perpendicular to that line? So the perpendicular gradient is then, if this is, for example, 2 over 1, then to get the perpendicular gradient, I change my sign. So I'm going to have a negative, and then I swap my numerator and denominator, which then becomes 1 over 2. Right, and now we need, now we have our gradient for this line, and we have the point 5 and 3. So now we can just substitute it into this form of the straight line formula, x minus x1, and we have y minus 3 equals to, so the gradient's negative a half, and x minus 5, and then we just simplify. So we have y minus 3 equals to minus a half x, multiply the negative a half into the 5 as well, we get plus, so minus and minus becomes a plus, 5 over 2, and then I just bring the 3 over, so y is equal to minus a half x plus 5 over 2 plus 3. Then to simplify that final step, y is equal to minus a half x. Then let's just put that on the calculator. We have 5 over 2 plus 3 gives us 11 over 2. And there we have it. So for question 31.2, we have to find the equation of the tangent to this circle at this point, minus 2 and minus 1. Now in this case, this equation is not in its standard form, so that's what we'll do at the very first thing. So minus 2x. Now it's already in its form that we can immediately start by completing the square. So I'm going to say add 2 over 2 and then square that. Then copy plus y squared plus 4y and add the coefficient of y, so that's 4 over 2 squared, and that's equal to, so 5. Now on this side I added 1 because 2 over 2 is 1 squared is 1, so add 1 on this side. On this side I added 4 over 2 is 2 squared is 4, so plus 4. Okay, then we just put it in its form where we have x minus and then 1 squared, because we take that x, that sign, and whatever is inside that bracket, plus, and then that y, that sign, and whatever is in that square bracket is 2 squared, and then this gives us 10. Okay, now that we have it in standard form, we can now establish, if I draw the circle, we can now establish, so we need our tangent, and the point is minus 2 minus 1, and we know now that this point over here is going to be 1 and minus 2. Okay, so that means if these lines are perpendicular, what I want to do in order to find the gradient of my tangent, I first need to find the gradient of the line from the center point to the circle. So this gradient, which is change of y over change of x, and substituting in my 2 points, I got minus 1 minus negative 2 over minus 2 minus 1. And this then is minus 1 plus 2, which is 1, minus 2 minus another 1 is negative 3. Alright, so there's the gradient, but now I need the gradient that is perpendicular to this line, and that would give me the gradient of this tangent. So this will then be a positive 3, or 3 over 1, or 3. Okay, so we have the gradient, we have the point minus 2 and minus 1. So substituting it into this form, so y minus negative 1 equals to the gradient, which is 3, x minus negative 2, and then simplify, y plus 1 equals to, so take the 3 in, that becomes 3x, take it to the next term, this minus and minus becomes a plus, and then times with this 3 as well is plus 6. Take the 1 over, and we're left with y equals to 3x plus 6 minus 1, so y is equal to 3x plus 5, and that is the equation of our tangent to the circle at the point minus 2 and minus 1. So now you should know how to find the equation of a tangent. Let's look at finding the lengths of a tangent from an external point. And in example 32, it says determine the length of the tangent from the point minus 4, 8 to the circle. Okay, so in this case, if we should draw this, we have our circle and we have a tangent. So just draw everything that they give you. And then the point, this point over here, is minus 4 and 8. And what we need to do is from this point, we need to find this distance to the circle, the point that the tangent goes through, that also passes through that point. And all we're given is the point and the equation of the circle. So what on earth are we going to do? How are we going to find it? And like I said, we need to find, or we need to put this equation in its standard form. So I'm going to start by just rearranging my terms again. Plus y squared minus 4y equals to 12. Then complete the square, x squared minus 6x plus 6 over 2 squared plus y squared minus 4y plus 4 over 2 squared equals to, so completing the square on this side, we added 6 over 2 is 3, so that's 9. So I've got 12 plus 9. And here we added 4 over 2 is 2, squared is 4. So we added 4. Okay, then we have x, this sign, and the 3, plus y minus 2. And this gives us 13 plus 12 is 25. All right. Now that we have it in standard form, we actually know now a little bit more about our circle. We know that the center point is at 3 and 2. And then we also know that the radius, see, the radius is everywhere the same. So we know this radius is 5. And what else do we know? We know that this is then perpendicular, right? And what we need still is we need this distance. But we still don't see whether we have this point or not. What we do know is if we connect these two lines, then we can actually find the distance between the center of the circle and our exterior point. And why would that actually help us? If we look closely, we see that this is a triangle and it's actually a right angle triangle. And when we have two of these sides, we can find the third one easily using Pythagoras. So this is the route we're going to follow. So the first thing we're going to do is to find our distance between the 2 points. So this is then going to be the distance, and I hope you know the distance formula. So we have minus 4 minus 3 squared plus 8 minus 2 squared, and then take the square root of that. And here we'll have minus 7 squared, so that's 49, plus 6 squared, which is 36. Okay, let's just work that out on the calculator. Square root of 49 plus 36 gives us 85, square root of 85. Okay, now that we know that distance, all that's left to do is to find our distance from our point to the tangent or to the circle. And let's call that one x. Right, so that means that if x, see the distance is a hypotenuse side, so that means in Pythagoras your distance squared is equal to your s squared plus x squared, the two short sides squared. So I want to find x. That means to find x, I'm going to take the s to the other side, and it becomes distance squared minus this, not s, sorry, this is a 5, 5 squared. So this is then going to be my distance squared minus the 5 squared. Let's just substitute in the known values, and to find x, put x on its own, we square root this. So x then is the square root of what is my distance is 85, square root of 85 all squared minus 5 squared, and the square root of that. And then let's just put that, or actually this is quite easy to do actually, because the square root and this 2 will cancel each other out. So this is 85, and then the square of 20 is, this is 25 minus 25, and then this is 60, square root of 60. Let's just see if that's in its simplest form. So the square root of 60 is 2 and square root of 15. Okay, so that is then the length of the tangent from the point minus 4, 8 to the circle. Then for question 32.1, so this circle has a tangent from this point. Let's just draw that for ourselves. And we have, well, this one is easy. We already have the equation in its standard form, but we want to know from this point, minus 4 and 6, how far is it from the tangent? Now, also look at this. This is from this point, or we could find the tangent from this point. Both these, and that's also one of your theorems in geometry, is that the distances are always equal from to an exterior point. The two tangents will always be equal to the exterior point, and that also means that you can choose anyone to work with, right? So what else do we know? We know that the center of the circle is -1 and 2. We also know that the radius is 3, because radius squared is 9, so my radius is 3, and we need to determine the length of PA. So point A is on the circle. I've got A here. All right, and we can now just connect these two dots and find the distance between them. Let's call that D. So the distance is the square root of -4 minus -1, and we square that, plus -6 minus 2. Square that. So the square root, -4 plus 1 is -3 squared plus 4 squared. So this will then give me 9 plus 16, which is 25. So this is equal to 5. All right, so our distance being 5, and this point, let's call this let's make this point C for the center. Then we know from Pythagoras that CP, if this line D with the distance D is CP, we know that CP squared is equal to the two shorter sides added together squared. So this is AC squared plus AB squared. But what do we want? We want AP squared, so I'm going to take AC over to the other side. I'm just going to write AP as the formula. So we have CP squared minus AC squared. And then we just substitute in the values that we know. And AP is the square root of CP. So CP is the distance we found, which is 5 squared. Minus AC is 3, so that's 3 squared. And this then gives us 25 minus 9, and that's equal to 16, and that's equal to 4. And that is our distance. Then for the circle, x minus 2 squared plus y plus 3 squared equals 34 has a tangent drawn from this point. So once again, let's draw it. And our point is somewhere on the outside, which is 4 and 5. And then determine the length of the tangent. So I'm going to name these again. So this tangent goes through there. I'm going to name it A again. And then the center of the circle, I'm going to say is C. And we need to, what do we have? Let's see what we have and what we need. So we already have the center of the circle, that is 2 and minus 3. And we know that the radius is the square root of 34. Okay. And then we just need this to calculate the distance over here. So this is AP. Now AP, the distance of not AP, of CP is the square root of 5 minus negative, let's start with x, 4 minus 2 squared plus 5 minus negative 3 squared. Alright, and then we simplify. So this is 2 squared, which is 4, plus this is 8 squared, which is 64. And this then will give us 68, square root of 68. Okay, so here we have the square root of 68. And then what's left is to find AP. Now AP squared will be equal to the long side of the hypotenuse minus the other short side of the hypotenuse squared. So we have CP squared minus the short side AC squared. And then to find AP on its own, we just take the square roots and we can substitute on our values for CP. It's going to be the square root of 68, that's squared, minus AC is the square root of 34, that's all squared. And then to simplify this is pretty easy because these square roots cancel. Just make sure this big square root, the bigger square root, can't cancel with one of these squares because they aren't multiplied. It's two terms, that's why you can't do that. So you have to cancel the smaller one with the one directly inside the bracket. So this then gives us 68 minus 34, and if I subtract these two, I get 34, square root of 34, and we can just check that that's its simplest form. Square root of 34 gives us, yeah, so that is its simplest form, and then that means that is the distance from the point to the circle. Okay, so that was length of a tangent from external point, and then we are finished with this video.